Erythropoietin, also known as EPO, is a glycoprotein hormone that regulates oxygen levels in the body. It was developed for use in anemic patients, individuals lacking red blood cells. However, in the 1970s, professional athletes began using EPO to enhance their performance. The International Olympic Committee banned EPO use in 1985. Lance Armstrong was involved in perhaps the most notorious doping case, being stripped of his 7 Tour de France titles. Armstrong is not the only professional cyclist or athlete to have been accused of EPO use. Depicted here is a schematic diagram of the method of action of EPO in the body to upregulate the production of red blood cells. Red blood cells are composed of hemoglobin, which stores and transports oxygen throughout the body. EPO is naturally produced in both the kidney and liver when red blood cell count falls below a threshold value. The process of upregulation is a hormone-dependent signaling pathway, working through 3 different steps of which we will now examine more closely. Step 1. EPO, which is a glycoprotein hormone, binds to the JAK2 receptor. The JAK receptor is a kinase, an enzyme that takes energy from ATP to activate a substrate. Step 2. The substrate STAT, which stands for signal transducer and activator of transcription, is phosphorylated by the breakdown of ATP in order to functionalize the molecule. Step 3. The STAT structure transcribes DNA in order to signal the enhanced production of red blood cells. A knowledge of the biological method of action as well as the biological composition of EPO is necessary to fight the widespread use of this performance-enhancing drug. Engineers having both a knowledge of engineering principles as well as biological systems are needed to design test methods and machines for such organizations as the World Anti-Doping Agency. In addition, new forms of EPO are constantly being developed that are undetectable by current testing methods. In order to prevent cheating in the professional sports realm, BSc engineers need to adapt and change developed methods of detection for these types of substances, using their problem-solving abilities in addition to their biological knowledge.